All right, so in this problem, we are not on the right problem. We got to go back a couple of spots. There, a little bit too far. Okay, here we go. It says if the reaction N2O4 yields 2NO2, has a Kp of 0.660 at 319 K, what is the Kp for a different reaction? So here's the question that I would like to ask. How is this equation right here going to be different, or how is it different, Brianna, from the original question, which is right here? Okay, it has simply been doubled. So what do we do, Abby, when we take an equation and double it? What's going to happen to its Kp? Okay, it's going to be squared. So we're going to call this Kp prime for A. We're trying to figure out what its Kp is. Kp prime for A is going to be equal to the original Kp. And since we took the equation and multiplied all the coefficients by 2, we're going to take the Kp and square it, because remember, your coefficients are your powers. So that's going to look like this. 0.660 is the original Kp, and that's now going to be squared. Agreed? Okay, and I know you can do the math, so I'll leave that up to you. All right, the next one, B. We're going to call this one Kp double prime, and we got to figure out how did this equation right here change from that original equation up here. So Hayden, help me. Tell me how that happened. What happened? Okay, it's been flipped and the coefficients have been multiplied by 1/2. So that means that the Kp has to be reciprocated. Agreed? And because all the coefficients are now half, then we have to raise this reciprocated Kp to the 1/2 power. So it's going to look like this. 1 over 0.660 raised to the 1/2 power. You could also say the square root of 1 over 0.660. Yes? Okay. That's question number 1. We're ready to move to question number 2. Question number 2 says, I'll grab the highlighter. It says, given the reactions 1 and 2, which are right here, what is the value of the Kp at 298 K for this reaction? Let's highlight this reaction. All right, so what that means is I'm looking for the Kp, but I can't do anything but use these two equations, somehow manipulate them, add them together. We call that Hess's law, do we not? Okay, so we're going to somehow manipulate them and then add them together so we can get this overall reaction. We will thus have to apply the rules to these Kp's before we multiply those Kp's together. And when we do multiply them together, that will achieve for us this Kp here. All right, so let's focus on two things. Let's focus on, see if I can make him a little smaller and we'll get purple. Let's focus on the CO2 here and the CO2 here. Okay, so I want to talk about this CO2. Nyreek, is it on the correct side in this equation? No, it needs to be on the other side. And what else does it need? To be cut in half, which means we're going to take this Kp right here, we're going to reciprocate the Kp and raise it to the 1/2 power. Yes? Okay, so let's look at equation 2 and let's focus this time on, and I'll get that and make it a little bit bigger. Let's focus on the CH4 right here. All right, Mariah, where do I want my CH4 to be? On the reactant side. And is it on the reactant side when it's here? No. And does it have the right number? No, it needs to be halved. So that means the same thing is going to happen to this Kp. It's going to be reciprocated and raised to the 1/2 power. So let's show what that looks like. So we're going to take the first equation, we're going to flip it and raise it and multiply all the coefficients by 1/2. So 1/2 CO plus 1/2 H2O is going to yield an equilibrium 1/2 CO2 plus 1/2 H2. That Kp is going to be reciprocated 1.9 1 divided by 9.8 times 10 to the 6 raised to the half power. Agreed? Okay. The next equation, which is 2, is going to do the same thing. We're going to flip it and multiply all the coefficients by a half. So 1 half CH4 plus 1 half H2O yields an equilibrium 1 half CO plus 3 halves hydrogen. And so that Kp of 8 times 10 to the 24 is going to be 1 over 8 times 10 to the 24 raised to the 1 half power. Did I put positive 6? It definitely needs to be to the negative 6, because if I'm going to reciprocate this number, I want to make sure that it goes from being, Hayden, reactant or product favored right now, right here? It's reactant favored, and when I reciprocate it, it's going to definitely make it, Nairi? Product favored. Thank you. Okay, so I definitely need to make sure, thank you, Jordan, that I have my negative 6 here. Let's talk about this one, Ashley. Originally, this fellow right here, that Kp, 8 times 10 to the 24, tells me who's favored. It's product side, because that's a big number. And remember, these K values are products divided by reactants. So that big number says product favored. All right, Skylar, if I take that number and reciprocate it, what have I done to the reaction now? I did. I flipped the reaction. But if I take this value right here, this one, and I reciprocate it, what does it tell me about who's favored now? It was product favored as is right here. Now it's going to be reactant favored. All right. So last little process here. Cross out whoever can cross out, which is 1 half CO. That means he's starting as a reactant. He's ending as a product. So, Jordan, catalyst or intermediate? Catalyst. He started as a reactant here. He ended as a product here. We cancel him out. He's not in the overall reaction. And I put everybody else together, which is 1 half CH4 plus a half and a half makes 1 H2O in equilibrium with a half CO2. And this is going to be a half and 3 halves. That's going to give me 2 hydrogens. Now, those two values, in order to get the Kp of the overall reaction, you're going to take 1 over 9.8 times 10 to the negative 6 raised to the 1 half power and multiply it by 1 over 8 times 10 to the 24 raised to the 1 half power. Now, I know you can do the math, so I'm not worried about us putting the math up here. It's the process. This is the chemistry. I trust that you can do the math.